So this is just really a brief summary of the key points, key issues that were raised within track 3, and the things that we discussed after the presentations and at the end of all the presentations as being the key points to bring forward and present here. I'd like to thank everyone within that track for their presentations. Very interesting. These are our design outcomes. So we wanted to have a review of existing efforts that were currently ongoing around the world. What efforts were needed, whether there were any possible collaborations in terms of tying laboratory experiments and field tests together, looking at the techniques for measuring boiler operating parameters, looking at the measurement techniques required to improve the quantification of exfoliation of tubes. Tube blockages, we heard yesterday about the pre-modelling activities and the work there, looking to predict how much blockage and where it occurs. And also, the last point was maybe some guidelines for handling of specimens of tubes and exfoliated scales from primarily service, but also extend this to the laboratory as well. Everyone's got their own particular preferred method of preparing their samples, and there was some discussion as to whether, depending on how you polish, how you prepare your samples, you could get one answer, and in another way might give you another value. So what I'm going to do is basically run through those key points and pull out the issues that came from the presentations and from the discussions in there. So if I miss anything, if I misinterpret your notes, just pipe up at any time. Okay, we heard from Japan how they've got a lot of experience with peening of material and the performance of peen surfaces. One of the issues that they're trying to work on at the moment and to get a better characterization on is the lifting off of the oxide scale. So not full exfoliation, but more of a blistering and a localized overheating, and how to characterize and quantify that. Within the US, there's work through EPRI and Oak Ridge. There's the work that NETL are doing in terms of the UK-US collaboration that we were aware of. Again, this is some of the work there is looking at developing more standardized testing approaches so that we can get better into comparison between laboratories.
Tony, can I just make sure that our first bullet is the 91 and not 9 chrome?
9 chrome.
G91. 91.
Yeah. At NPL, we've got activities, obviously looking at the effect of heat flux. Done some work on CTE. It sounds like that might be an area where we want to revisit in future programs. We heard from Rudolph about the test work, the loop test work, and that presented some interesting results there from some peen samples and some of the loop test samples showing the difference in the oxide thickness with relation to coarse grain and fine grain material. There's peening studies going on at AEP, and we had a nice presentation on 4 oxide thickness measurements from EON. So there's activities, there's things going on. Whether we can pull it together in a collaborative way is yet to be investigated. In terms of efforts needed going forwards, data collection was an area we flagged up. One of the things that we thought would be useful would be to have some kind of standardized test report that could be applied for field studies so that there was some kind of standardized set of data that was coming back and everyone was collecting the same thing and presenting it in a similar way to make inter-comparisons between different utilities easier. Within the group there we thought that would be an activity that perhaps would be best led by EPRI. It would have the respect from the utilities being done within the industry rather than the likes of MPL trying to force a set of recommendations on people. Round robins was raised. I showed some results from 10 years ago and some results from more recent studies. So there's a general agreement that more round robin work would be useful to try and get the results more comparable. It was also mentioned that it would be worthwhile to do some repeatability tests within one laboratory. So to get some kind of handle on what the scatter is between repeat tests using the same apparatus, but perhaps using a different operator. Just to put the kind of scatter we see in round robins into some kind of context. We heard from Eon about the bore oxide thickness measurements using ultrasonics. That's fairly thin wall components. So it was raised whether we needed to do some efforts on thicker walled components. And some work on comparing different material types. Again, in the course of the presentations yesterday, we heard how there were differing views from the US to the UK. Now, I think we've got this right the right way. In the US, you're primarily using 347 and 304, whereas in the UK, we're using 321. So doing some kind of comparison between the properties of those three materials might account for why we're seeing different types of behaviour on the different sides of the bond.
That's about 30% in the UK, we also use 316.
316 as well. Thanks.
And just to make clear, there's lots of 321 in North America and in other places. The one that there isn't any of is 316.
Okay.
Right?
Just comment on data setting as well. We rarely see the actual chemistry still being tested. You can see it's grade 347.
Yeah.
Yeah, I was going to say, grain size, the data Professor Masayama showed was just varying, pretty large variation, 347, even within Japan, by just looking at the different specs they made to the ASME spec and the Japanese spec, because they have actually different allowable grain size ranges. Some of that could account for just grain size alone. So.
I think there's something we wanted to look at in the UK, US. Quite happen, I don't think. Looking at the difference in the oxidation kinetics within the composition envelope of a particular alloy. You have a range of, say, the silicon content and how much of an effect does that have?
Yeah, it's very important, and that's why you'll note in the slides that I showed yesterday, we try to do that analysis every time, but we can't always get the client to pay for it.
Okay.
That's the big thing.
Yeah.
And so that's part of what I was talking about when we do this low quality database, is to make sure that we have the samples, not just the photographs, so that can be done. Very important.
Good point.
Most of the customers not have chemistry from the bottom to it.
Sorry, Peter.
Do they not have the chemistry from the bottom to it?
Well, most of if you read the acknowledgements on my paper, you would see how we get those samples, okay? We get them because of failures, and we're usually doing failure analysis. And when we do failure analysis, they generally don't want to unless they are specifically, or we tell them they're going to do it from the chemical analysis. We can do it, there's no problem for everyone, but it's just not something that a lot of clients are not enough to pay for.
Moving on to possible collaborations, there were a couple, well, there's one in particular that was raised during the presentations, and then just a general request, really. Raj presented some interesting work at Genom, where they've been using EFBT to survey their tubes, the superheated tube banks, and they've got data collected showing percentage blockages on different parts of the superheater. So we felt that if that could be supplied to feed into the modelling work for EPRI, that would be useful. There's another general request that within research laboratories, supply of material can often be difficult. So if the industry, the utilities are able to supply tubing, fruitfully received, so plant exposed tubing too. We spoke about some of the techniques being used, so the borescope, ultrasonic techniques. We've heard how they're being used for permanent life in the UK, and that's with ferritic materials. When we go to austenitics, the oxide thickness is smaller, so we need to look at that going forward. Metallography techniques. We saw some results looking at the hardness and relating hardness to oxide thickness. We spoke about whether thermal imaging would be a useful tool for identifying where we're getting lift-off, blistering, exfoliation. And we spoke about some other ultrasonic techniques, the EMAP and phased array. Quantification. We felt we needed to do some work on the quality of metallography for voids and cracking and phase identification. Maybe recommendations on the best approaches for different types of materials, perhaps. We need better statistics on oxide thickness measurements. More work on peening. I know that the Japanese have a long history. We also need to think about how long the peening effect actually lasts and how that varies with temperature, perhaps. And also the analysis of exfoliated material. One of the things that was discussed in our session was if you had a bag of spooled oxide, it would be useful if you could determine how much was coming from ferritic material and how much was austenitic, and it would give you an indication of where your problems are occurring. So these 2 points kind of relate to how you might go about doing that analysis, whether it's a wet chemistry, X-ray diffraction, XRF. It's mentioned in some of the other tracks as well, but the quantification of the size and quantity of scale. So how big are the pieces, what kind of geometry are they, what number proportion is coming through. That was something we thought needed some quantification as well. I think this is the last issue. Blockages. So we heard a nice presentation where this technique has been used to identify the amount of blockages and where they're occurring and if there's an issue. I believe it was over 40% blocked, in which case it would be the tube was cut and cleaned out. Otherwise, the tube cleaning procedure was followed whereby the plant was at full load for a length of time, and that was good enough to blow the exfoliated scale through the superheaters. We've also heard about a simple analysis check where a simple gauge can be used on superheaters to see whether you've got bulging. Last one is towards the guidelines, kind of repeating what I've already said. So standardized metallography techniques, agreement on terminology. To a certain degree, this will come through on the ISO documents, so that everyone knows that everyone's talking about the same thing. Some guidance on terminology to use, and how to prepare the specimens would be